Guys, welcome to the next section of our studies on calculus. Today, we are looking at the limit at infinity and the continuity of functions. And here, we are going to learn on how functions behave at the end. Now, let's take our time to understand the concept of limit at infinity. Limit at infinity describe the behavior of a function as the input value x becomes very large. When it becomes very large, it means that the value is approaching positive infinity, and that is how we denote infinity. And or very small, that means it is approaching negative infinity. Unlike standard limits, which examine values as x approaches a finite number, we normally see it as x approaches 2, x approaches 0, x approaches 10, x approaches this number, -5, and so on. That is the standard limit. X is approaching a finite number, but this limit helps us to predict how a function behaves far out on the graph. That means far from the finite number that we are talking about here. So here, what we need to understand is if we are studying limit to infinity, then we need to understand what infinity is. Infinity, which is denoted as this particular symbol, is not a number but a concept. And what concept is that? This concept expresses extreme values. That is, values that are very extreme. That is, values that are very, very large, or values that are very, very small. So here, a function f of x has a limit at infinity if the values of f of x get closer and closer to a specific number as x approaches positive infinity or x approaches negative infinity. So limit to infinity is particularly useful when, one, we are sketching graph in a quick form, that is sketching graph quickly. Then number two, when determine horizontal asymptotes. So if you want to determine horizontal asymptotes, limit to infinity is very useful. Then number three, which is very, very useful here, we have limit to infinity help us to analyze real-life phenomena involving very large quantities. So if you are analyzing a phenomenon or real-life situation which involve large quantities, limit to infinity is very, very useful. So in short, what we need to understand is such that limit at infinity help us understand the long-term behavior of a function. So if you want to know the long-term behavior of a function, we stick to limit to infinity. Now, let's understand limit to infinity by using this particular concept. We are to find the limit as s approaches positive infinity or negative infinity of this particular function, which is x plus 1 divided by x minus 1. We are analyzing how the function behaves as x becomes very large in either positive or negative direction. So here we have to we consider the table of values and the graph of f of x of this particular function, which is x plus 1 divided by x minus 1 as x approaches very large number, which is positive infinity, and x approaching very, very small number, which is negative infinity. So let's look at this particular table. We have the x here, we have the f of x here. Negative infinity, -1000, -100, -10, -1, 10, 100, 1000, and infinity. We have selected this particular range of numbers from negative infinity to infinity to look at the behavior of the function when x is approaching infinity. So when you have negative infinity, we have an answer to be 1. -1000, we have 0.9980. -100, we have 0.980. -1, 0, we have 0.818. -1, we have 0.008. 10, we have 1.22. 100, we have 1.020. 1000, we have 1.002. Then infinity is 1. What it means is that as x approaches infinity, the behavior of f of x is such that it is getting closer to 1. Now let's look at the graph of this particular function. We are having the graph of this function in this form. Look at y equal to 1. So y equal to 1 is the red line at this particular section, and it is the asymptotic line, and it is asymptotic to the function in this direction and also in this particular direction. So look at the graph very well, then you understand that the values of the function or the behavior of the function is such that it is getting closer and closer to y or f of x equal to 1, but it is not touching it. So what it means is that as the s value, that is the input value, becomes very large, the function gets closer and closer to 1. So as limit simply means the approximate value, we can simply say that as x approaches infinity, then the limit of this particular function or this function behavior will be approximately to 1. That is y being equal to 1, where this one becomes the horizontal asymptote for the function. Now the value of the function gets closer to 1 but never actually becomes 1. So the behavior summary is such that as x approaches negative infinity, f of x approaches 1. That is the limit value, that is the approximate value. Then as x approaches positive infinity, f of x also approaches 1. So what it means is that function never reaches 1 and it is horizontal asymptote at y equal to 1. So if someone asks you what is the limit as x approaches infinity of this function, using the table on this graph, it means that the limit as x approaches infinity of this particular function means that the function move closer to 1. That is, f of x will be equal to or approximate to 1. Now let's understand how we find limit as x approaches infinity of this function without using graph or table. Now let's note that when you have 1 divided by an infinity number raised to the power n, where n is greater than 0, which means that n is positive. For example, we have 10 power 2 equal to 0.01, and it is also approximate to 0. We have 1 over 1000 power 2 equal to 0.001, which is also approximate to 0. So which means that when you have 1 divided by infinity raised to the power n, where n is a positive number, the whole of this expression will be approximately be 0. That is, we'll have a whole number of 0. So in this form, if we want to solve this particular problem without using graph or table, what are we going to do? The best thing to do is to try to bring the expression of each term in this particular function to be of the form 1 divided by infinity raised to the power n, where n is a positive value. So here we have to make sure we divide each of the term by the highest index of x. So x here we divide x plus 1 divided by x plus x divided by x minus 1 divided by x. The motive is to create an expression of this form. So here we are going to end up with 1 plus 1 over x divided by 1 minus 1 over x equal to 1 plus. So when you are working out for the approximate value, that is the infinite limit, we do substitute the value of x to get the approximate value. So here we are going to substitute x as infinity, then the infinity sign here. The whole of this expression is behaving like this expression, which will be approximate to 0. So here we are going to get 1 plus 0 divided by 1 minus 0, and the answer is 1, which confirmed from what we did earlier using the graph or the table. So now let's move to how we can evaluate limit at infinity without using graph and table. More examples for us to solve. So we have to evaluate limit as x approaches infinity of 3x squared plus 5 divided by 2x squared minus x. So what will be the solution? Here we have to divide each term by the highest power, which is x squared, to create an expression of the form 1 over infinity power n, where n is a positive number. When you do that, the whole of this expression, as we've learned earlier, approaches 0. So here, each of the term, 3x squared, 5x, 2x squared minus x, all of them will be divided by the x squared. When we do that, the expression will be simplified as the limit as x approaches a large number, that is the infinity, 3 plus 5 over x squared divided by 2 minus 1 over x. And when you substitute your infinity sign, we are going to end up with this particular expression. Then note that 5 over infinity square will be approximate to 0. 1 over infinity will also be approximate to 0. Hence, this is what we are going to do. It means we are going to substitute 0 for this expression. Then we are going to end up with 3 plus 0 divided by 2 minus 0, which will give us 3 over 2. So it means that the approximate number for this particular function when x is approaches infinity will be 3 divided by 2. So that is the behavior of the function as it is approaching infinity. Now let's move to example 2, where we have a function of the form 4x cubed minus 7x squared divided by 2x cubed plus 5. We have to find the limit, the behavior of the function as x is approaching infinity. What are you going to do? Repeat the same process. Divide each term by the highest powers of x, which is x power 3. In this particular form, we are going to divide the 4x cubed, 7x squared, 2x cubed, and the 5 by x power 3. When you do that, the expression will be simplified as this form. And remember, we are going to substitute the x value in the expression. And when we do that, we are going to end up with 4 minus 7 over infinity, 2 plus 5 divided by infinity squared. So in doing that, remember, the whole of this expression will be approximate to 0. The whole of this expression will be approximate to 0. And our answer is 4 divided by 2, which is equal to 2. So let's move to example 3, where we have a square root. This one, we have to be very careful and analytical when we are dealing with limit to infinity of this particular function. So here, we have to understand that the limit to infinity of this function can also be expressed as x divided by square root of x squared, then bracket 1 plus 1 over x squared. Here we factorize the x squared outside, then put the rest of the expression in a bracket in order to have a simplified and simple expression to deal with. But note, when you have square root of ab, is the same as root a times root b. So in this form, therefore, what we are going to do is the square root of x squared 1 plus 1 over x squared will be the same as root of x squared times root of 1 plus 1 over x squared. So the whole of this expression, the x squared represents the a and the b represents 1 plus 1 over x squared. When we do that, we are going to end up with a simplified expression as x square root of 1 plus 1 over x squared. In doing that too, we are going to also end up with lim x approaches infinity, x divided by the x is now outside, square root of 1 plus 1 over x squared, which we are going to analyze this situation in this form. Remember, whenever you substitute the infinity sign as your x, the whole of this expression will be approximate to 0. At the end, we are going to get 1 divided by square root of 1 plus 0, which will be 1 over 1, and our answer will be 1. So that is all about limit to infinity. Now there is a practice section for you to try your hands on them. Don't forget to send your answers to this particular channel, and I'll continue to be your help. So don't forget to subscribe and follow this particular channel to continue to receive the best of high school math education. Thank you.